Hello everyone, welcome back to the workshop. Today we are taking a look at a new laser, and this one has a feature that we're starting to see on a few different modules from different manufacturers, and that is that it has a switching power rating. So this one is the iKier K1 Pro Max, and this has a 48/24 watt power rating on it. So it has this switch on the side here. We're able to switch between 24 and 48 watts. So I want to take a look at this and see how it performs in both settings, see what the differences are, see if we get a higher quality engraving out of the 24 watt, and also see how it performs as far as cutting and blasting through material on the 48 watt side. So we're going to dive into this. So if that's something that sounds interesting to you, stay tuned. We'll get right into it. All right, so I have the laser unboxed, and at least this version of it, the frame has come all assembled, and so their instruction manual doesn't have too many steps to it for us to do. Really, the step one is just getting our rails, our side points to the front. Then we're going to need to attach the top rail. We take the top part off to access some of the wiring and such, put our module on, and then finish some of the wiring. So I'm going to breeze through this really quick, get it all assembled, and we will just then jump right into the testing. So we have the machine assembled. The way they have the frame kind of all in one piece made it a lot easier. Really consisted of just putting that top rail on and getting our hoses and wires in place. So definitely nothing that takes a whole lot of time with this one. Now, I don't want to go too in depth into all the features of the K1 series, as I've already done a pretty in-depth video on the 24 watt version of this. So what I want to do is highlight the features of this specific one with that kind of dual power head of 24 and 48 watt. Now, this does also have the other features that we like seeing. It has the automatic air assist that you can turn on and off through the M8 control, as well as a powered Z access that allows for autofocus and lower depth. So again, if you want to see some of the features of that, I'll link down to my 24 watt version video of this, so you can check that out as well. But wanted to really focus this video on the differences of the module, being able to switch it between 24 and 48 watts. So as always, the first thing I always do is material tests, and I generally start out with a cut test. So one of my popular mediums is using 1/8 inch or 3mm Baltic birch plywood, and that's what I have here. I have this sheet that we went ahead and cut initially with the 48 watts on this side here. And as you can see, hopefully we got all the way up to 800 millimeters a minute, cutting through at 80, 90, and 100% power. So before moving on, I went ahead and ran the same test, but just switching down to the 24 watt setting. And as you can see, we got through at 550 at 100% power. So as you can see there, it's not half, it didn't cut it down in half from that test, but knowing that we also were cutting through at 80%, I wanted to test out the 48 watt, bumped it up to going to 1,000 millimeters a minute, and it did squeak out that last one. There was just a little bit of a fiber holding on, but it just poked out really easily. So we were able to get up to 1,000 millimeters a minute cutting through with the 48 watt at 100% power. Now, I don't feel like that would be something I would consistently trust, so I would probably back that off about 15%, and I would run this probably at 900 millimeters a minute and 100%, 90% power for this material. And remember, just because this is 1/8 inch material, that's not going to hold true for all. Some may even cut faster. If you have 1/8 inch basswood, it doesn't have to cut through the layers, including the glue. It's going to go faster. For initial cut tests, very happy with this, and we can definitely see the difference between 24 and 48 watts. So moving ahead with the cut tests, I stuck to the 48 watt setting because that's really the advantage of this, is that you can crank up to that higher power setting to really blast through material. but then when you want to have finer detail and such, you would switch back to the 24 watts. So these additional couple of cut tests were done solely on the 48 watt setting. And so I have some 1/4 inch or about 6 millimeter material, and this is about a 7-layer plywood. And as you can hopefully see here, we were getting through this at 650 millimeters a minute. My letters are a little blown out there just because I had too high of a power setting for the text, but 650 millimeters a minute, 100% power. We were still able to get through this 1/4 inch plywood. And again, you know, that's much faster than most of the other diode lasers I've been testing. So definitely seeing the advantages of having that 48 watts of power. Not a whole lot of extra fibers hanging on in this one, and that can be attributed also to the material itself. Some will have just more variation in the fibers. Others will be fairly clean. This one was fairly clean. I didn't have any that were really hanging on. They dropped out. But then when they weren't coming through, that was definitely because there was a lot of fibers that it just didn't cut through. So with that, I went ahead and jumped into some maple, and this is just a touch over 1/4 inch. And so this is kind of a harder maple. This is definitely going to be pushing the abilities of this laser. I kept it at the same 400 to 700 millimeters a minute, and we only got through 400 millimeters a minute at 100% power. But again, this is a single pass, and that's still a pretty decent speed. You know, I could definitely bump this down and go from 250 to 400 and really dial this in. But the ability of this to be able to move through material, thicker material and sometimes more dense material at, you know, decent speeds is great. So with some of our initial cut tests out of the way, I wanted to jump into doing some raster engraving tests. And so I have this kind of scaled engraving test that I do. And we started out right away with the 48 watts at 2,500 millimeters a minute. And so these top two ones here, this one top one is the 48 watt setting. This is the 24 watt setting. These are both run at the same settings as far as DPI and speed. And you can see there how they came out. Now the big difference here is that have a little more of the whiteness on the 24 watt setting. But on the 48 watt, we're definitely getting a darker engraving, a little bit deeper engraving there. And our lines are a bit more crisp. You see them just starting to fall off here on the 24 watt setting. So wanted to then jump it up in speed. Now this laser is rated to be able to run at, I think it was 900 millimeters a second, which is about 54,000 millimeters a minute. So I checked the settings, and in the hardware, it was set to 50,000 millimeters a minute. So that's what I ran it at. And here is our test results here, these two. Again, the top one is the 48 watt, bottom one is the 24 watt. We're definitely kind of losing a lot on the 24 watt. 48 watt is decent. It's probably usable, but we are, again, like the 24 watt at the 2,500 or 25,000, just starting to see some drop off in our lines here, but definitely a pretty decent gradient. You want it to be about halfway in the middle. You still want to have a little bit of definition here in the upper levels, and we just kind of have it, but you know, maybe needing to back that off a little bit. So then really trying to dial in our 48 watt settings. I went ahead and ran it at 4,000 millimeters a minute and then 35,000. And those are these two. These again are both 48 watts. So this is at the 4,000. This is at the 35,000. And at the 4,000, we're still just getting a little bit of drop off on these lines. We're still having a decent gradient. So I just slowed it down a little bit. And here's where we ended up at with the 35,000 millimeters a minute. I felt like we were getting just enough detail in those lines, a pretty good gradient, that I felt happy with that being the speed. Again, that's for this material. Different materials will burn better. So you do have that range of speed option to you to really kind of dial it in your settings. All right, so knowing that we had the two different options of 24 watts and 48 watts, I went ahead and did an actual photo engraving. So this is a photo I pulled off of laserpics.com. That was a free photo that's pre-set up. All I did was select I actually took the default DPI, which I think was 428 or something like that. And it ran each one at kind of the speeds I had dialed it into. And here is the results. So on this side, we have the 24 watt. This was ran at 35,000 millimeters a minute, took 6 minutes, 24 seconds. And here is the 48 watt. We ran this at 42,000 millimeters a minute, and it took 6 minutes, 34 seconds. So they really took about the same time. And even though this one was running faster, I did have overscanning set up so that it moves past the image and doesn't stop right at the edge. That can cause some issues with extra burning on the edges. So I have it set up to move further. Well, the faster you're going, the more it has to travel out past, stop, re-accelerate back to the other side. So that probably accounts for some of the discrepancy, as well as we're working with a finite area. It can only, you know, speed up and decelerate in so much space. So we might not be actually hitting these specified speeds, but the difference that I want to look at is just the quality of the photo. Now, you will notice that the 48 watt one is darker, maybe has a little more contrast. However, if I can get in close enough, you will start to see that some of the details are just getting blown out. So on the 24 watt, we're definitely seeing more detail in the fineness of this. So there's little specks down here that you see quite well. There's a lot more lines around these various stars and such, where over here, those are really kind of getting blown out. They're just, the beam width is a little bigger, it's a little hotter, and so it actually adds to more burning. So you are definitely going to have some differences to play with there. You may get a little more detail out of the 24 watt settings, but you may have a little more color depth with the 48 watt. Now there's obviously a lot of things that can go into play with this. Power and speed can help you get a darker burn, but at a slower speed on this. So it's going to be up to you to decide which settings work well for you. Are you just going for, you know, I need it to be fast, I need it to be dark. You might want to bump up to the 48 knowing you're going to lose a little definition, and maybe your image is a vector image and you're okay with that. It doesn't have a lot of specific detail, or you can slow it down. You can use the slightly smaller spot size of the 24 watt, get a little more detail, just knowing that you might need to take a little more time, or it might come out as a little bit lighter. So another thing I like to look at when looking at these lasers is the kerf. It'll tell me a couple things. If I'm trying to do some offset or some inlays, I need to know that kerf so I know how much to adjust for the beam width and how much it's going to burn away so that I get real tight fitting parts. But it also gives me a little insight into how square or rectangular the beam is. I don't have a way to necessarily just measure the actual beam and its focus spot, but we can look at the results of a burn in both axes to identify, is this cutting at a wider in one direction than the other? That's going to be indicative of a rectangular beam. And so I like to run these square kerf cut tests. And so over here I've got the 48 watt cuts, and over here I have the 24 watt cuts. And one of the interesting things I started noting right away is that my measurements were coming out fairly close in both axes with just some slight variations. So for example, here in the x-axis we've got 20.28 for the outer cut versus 20.31 for the vertical cut on the outer side. And again, on the inside, the actual shape, it was 19.78 and 19.74. It's really great to see those numbers that close, because it's indicative that we have a much more square beam than when there's a less variation between the two. So I did that. I like to run the test a couple times. I take all the measurements, and what I'm doing here is measuring the difference between the object size with the cutout size, and then that will give us the overall width of both cuts. Divide that in half, that is the beam width. Now, if you wanted to do your kerf offset, you're generally going to then divide that again in half. So what I ended up coming up with for the 48 watt was that the x-axis, we had an average of 0.55 millimeters as far as the difference. So we divided that in half, so we were getting an approximate burn of 0.278 per line. And then for the y-axis, we were getting an average of 0.617. Again, divide that by 2, we're 0.308 millimeters for the burn. So again, very close in size. And so then we backed it off to the 24 watt, and what we were finding in the x-axis, we were getting an average of 0.34. Again, divide that by 2, so it's 0.17 millimeter. And then the y-axis 0.43 divided by 2, so 0.216 millimeter. And so again, you can tell from that our focus point is going to be a little bit smaller, because we're comparing it to the 48 watt where it was 0.278 in the X to 0.17. Obviously that's a little bit smaller. Same thing in the Y, 0.216 in the 24 versus 0.308. So there is a slight difference that we can measure between these two tests. But the thing that I'm really happy about is that across both of them, we're having fairly consistent measurements with just a little bit of variation. So that's going to make it a lot easier for doing, like I say, interlocking parts, inlays and such when that kerf is fairly close to both sides. So of course, with those 48 watt option and the higher cutting power, wanted to see how well we could cut through some thicker material. Now there are going to be limitations to any diode laser in the fact that its focal length really comes in and out of focus in a finite step. Now having this step down powered Z helps with maybe extending that a little bit, but it's still going to have some limitations because you're going to be having that wider beam on the entrance and then the finer spot in the middle and then a wider beam out at the exit. So once you get above maybe 30 millimeters or about 1.25 inches, you're really getting an ineffectual beam at thicknesses more than that. So, and realistically, for me, I test on some lighter woods that are, going to have a better chance of cutting through. Can you cut through thicker, harder woods with diode laser? Sure, but it's often going to take a lot of extra passes, a lot of time, might be kind of slow, and so it's a bit impractical to cut with those, and that's where you might start looking at other machines such as a CNC router or a much higher power CO2 laser for cutting through those materials. However, that being said, as we're stepping into these higher wattage diode lasers, it does open up more capabilities in some materials. So my tests on thicker material are in clear aspen, which is a less dense, less heavy wood, but it's still structurally sound in that you can make some things. And I limit it to about 1/2 inch to 3/4 inch, which puts it in the realm of practicality for making some cuts. So I did go ahead and do some test cuts. I started out with the 1/2 inch clear aspen and was pleasantly surprised. I started out at, I believe, 200 millimeters a minute, and it blasted right through. So I just kept stepping up to see how fast I could get and still have a clean cut. And what we ended up at on our 5th cut was we ended up at 300 millimeters a minute, and that is this smaller one here. This is at 100% power, a single pass, and we were just getting a very nice caramelized burn. We aren't getting a lot of charring, and the backside, there is a little bit of that, but I am going to attribute that again to my honeycomb. Just really needs a good cleaning, and that was just the residue on the honeycomb flashing. That wasn't indicative of the laser leaving a lot of marking on the backside. So very happy that with this 1/2 inch material, we were able to run at 300 millimeters a minute. Now I did have just, if you can see on here, there's just a little fiber there that was holding on. So I did have to just kind of push it through, but I felt that was acceptable in this material. So knowing that, I went ahead and stepped it up to our 3/4 inch material, and I've been able to cut through 3/4 inch aspen with a lot of the machines, but a lot of times I end up having to step it up to maybe 2 or 3 passes to get through cleanly without heavy charring and such. Well, this one was performing pretty well. Went ahead and started out again with our 250 millimeters a minute on the first cut, and then down to 200 millimeters on the second one, but unfortunately wasn't quite getting through on those. So I bumped it down to 175, and we did finally pop through. This one came out nice and cleanly, and here again you can see caramelized but not charred. And again, the cut on the front and the back fairly clean, just a little bit of flashback from the honeycomb there. So, and this was in one pass. This was one pass, 100% power with at 175 millimeters a minute, full air, and it worked pretty well. So that makes it a little more viable to be using some thicker material if you want to be able to cut out some items. Now again, at 175 millimeters a minute, it's not a speed demon, but you're doing it only in one pass, so it is going to be better than most. So of course, with that, wanted to take a quick little preview at how that would be practical, and went ahead and cut this little 3D cutout out of some 1/2 inch aspen. And I did back this off to just 250 millimeters a minute, ran it at 100% power and full air. Now this is about 5.5 inches wide and about 1.75 inches tall. And it took 4 minutes and 44 seconds to cut this out. This is the top, very clean, and this is the bottom. Again, just kind of some blow over from that residue on the honeycomb. This would sand off very easy, but again, reason to make sure you do some maintenance on your gear. I need to get that honeycomb out of there and get it cleaned up, and this would be a lot cleaner just straight off the laser. And then looking at the edge cut there, you see that it's nice and caramelized, a little bit darker on the bottom than the top, of course, but definitely very clean and not something that's going to look like it came out of the charcoal bin. So it's something very practical. Like I say, under 5 minutes to cut this out. You could easily make little nameplates for this and desk items. So just something I wanted to throw in there as a quick little project that showing the capabilities of the higher cutting power of that 48 watt module. So I hope this gives you a good overview of what is capable with the 24 versus 48 watt settings on the iKier K1 Pro Max laser. I was very happy with the performance of the cutting power of the laser and the ability to switch between 24 and 48 watts. I could see some definitely advantages when you want to get into maybe a little more detailed work with that lower power laser, but being able to switch it on and really cut through that thicker material is a nice option. Now, as we're seeing with some more lasers and more options coming in that's adding some features, we've got the auto air, we've got the powered Z-axis, and we're just seeing some more rigid frames with linear rails and other things. These are nice to see. They don't always come with smooth sailing. I did have some issues with the autofocus on here, and most importantly, it seemed to fail a lot after a homing operation. Really meant that I had to run this laser in current position rather than absolute coordinates, which is a little unfortunate that I kind of lost that ability to work natively in absolute coordinates, which is a lot easier to set up jigging on. However, it did perform well in the current position, and I was able to get through all my work. I am working with their support on this to see if there's a reason why I was having so much trouble on that, and I'll definitely follow up with that to hopefully have a fix. But we're going to use this laser in a few more things. I might try extending it with some rails, getting it into a larger enclosure. So definitely, if you want to find out more what I do with this laser, consider subscribing, and you'll see that content in the future. I will definitely have links down below if you'd like to find out more about this laser. Appreciate you checking those out, and hopefully that if I influenced your decision, that you consider using those links below. Some of them will be affiliate links that do provide a bit of a kickback to me at no extra cost to you, but as always, no pressure. I always just try to give you good information to inform you on your purchases. So anyway, again, that's where I'm going to wrap it up. I thank you for watching, and I hope to catch you again soon, but I hope you get out into your workshop and make something too. We'll catch you next time.